Ladies and gentlemen, welcome back. Another day for some calculus. So hopefully you're awake. Hopefully you're excited. Sorry I can't not be with you today, but you have a sub. And part of today is just going to be some review because nothing really new to learn, but some review. And I need to try to answer some questions that you might have. And so here's my thought here. Grab a whiteboard, grab a marker in the front here. And I'd like you to take a peek at the following problem here. I'd like you to find the volume of solids whose base is the region between these two functions, x squared plus 4 and 1 half x plus 1, from x equals 0 to x equals 2. But key right here, though, we're going to be doing this that's perpendicular to the x-axis. So we're going to be finding things that are perpendicular to the x-axis, and I want us to do it by using squares and by using semicircles. So I'm going to let you begin, and then the sub can pause the video here and see what you can get here for answers. See if you can find the base between those functions, and then how do I add up all those squares? So find the base of the square, what's the formula for area of a squares, and the same thing for semicircles. So a little review from yesterday, but I think that's good because some of us yesterday were swimming in this a little bit. So sub, you want to pause the video, let them try these, and I'll come back on and we'll work our way through this. All right, the sub hopefully paused it and take a piece and see. Well, number one, I need to actually figure out what this looks like. So if I made a fast graph of this, I'm going to have my function, number one here. So I'll use this one, x squared plus 4. I'm going to be starting up here at 4. It's going to make a parabola, shift it upward. So this is my first function. My other function is 1 half x plus 1. So pretend like that's 1. It's going to be going up 1 over 2. I'm going to end up getting something like this. Now, back me up, Mr. Royak. I'm actually going to undo this so you can see this better. Forgive me here. Let's do this. I'm going to slide this up a little bit, make this a little bit bigger. And if I graph this other line, this is at 1, then my other line is going to be going up like such. Now, I want us to find the area between 0 and 2. So I'm at 0 right here. And let's just say this is 2 right here. This is the area that we're looking at, though, is the area between these functions. Does that make sense? Now, I want these perpendicular to the x-axis. And so my shapes, again, and I know you guys were laughing at me yesterday, but my shapes now, if they're perpendicular to the x-axis, they're going to be going between my two functions. So the base of my shape, this is going to be the base of my shape, is going to be the distance between the red one and the green one here. Is going to be my base. And if you remember from yesterday, the key to all of this is it's all about trying to find what that base is, no matter which way I do it. Do it part B, do it part A, it doesn't matter. I need to find the base of this. And so if I want to find the base, since it's going up and down, it's going to be the difference between my top function, which is my x squared plus 4, minus my bottom function, so I take that one, minus the bottom one, which is the 1 half x plus 1. If I distribute the negative through there, I'm going to end up with this x squared plus 4 minus 1 half x, and then I'm going to have minus x, or minus 1, sorry. And so my base, when I get all said and done, is going to look something like this. It's going to be a negative, or sorry, not a negative, a positive x squared minus a 1 half x, but then I'm going to have plus 3. So that's going to be my base between my two functions. Now, if I go over to part A here, do this one first. If I want to use squares, these shapes now are going to make these squares that are going to be kind of going up, again, three-dimensionally out of the board here. Wherever this base is, these sides are going to be the same as well. And so I want to add up those bases, so the area of a square. Now, because I'm going along the x-axis, everything's going to be in terms of x, and so my bounds have to be in terms of x. So if I start out finding my volume, my bounds are going to be from 0 to 2 because I'm going from 0 and I'm going to 2, and I'm adding all the squares, all these slices going that way. It's just that, how do I find the area of a square? Well, the area of a square is just my base times my base, or my base squared. And so if I already know what b is, I'm just doing this, taking my calculator, 0 to 2, and I'm taking the integral of this x squared minus 1/2 x plus 3, but I'm taking this thing and squaring it because I want the base squared. So I don't know if that's what you did at all or not. I'd be fine if you use your calculator to do this, type that in. But I should get, again, probably a decimal when I do this. But again, make sure I square the whole thing when I type it in. I should get something close to this for my volume, roughly to be 31.06 units cubed. That's going to be my volume when I go to math number 8. Sure? Now, if I wanted to do a semicircle, it's going to be the same thing. I need to find the area of my semicircle. And that's just half of a circle, so it's half pi r squared. Again, Mr. Royak, here's where this is hard to see these shapes. But my semicircles now are going to be this now, where this is my base. My semicircles are going to make this shape here. These semicircles as I slice them through there. I just need to find the area of one semicircle. And so the key here is I need to find the radius for this. Well, if I go back again to this picture, and again, I've been drawing too many times on this now, so it's hard to see, but if my base is this distance going up and down, the radius is just half of this. So my radius is just half of that. So my radius is going to be half of my base. And so in our case, our radius is going to be 1/2, and then in parentheses, this whole thing, what my base was, my x squared minus 1/2 x plus 3. Or if you wanted to distribute that, this is going to be 1/2 x squared minus 1/4 x plus 3 over 2, 3/2. And so that's my radius right here. So if I wanted to find the area, my area is going to be 1/2 pi times my radius squared. Well, since my radius is this, I have 1/2 x squared minus 1/4 x plus 3/2. That's going to be the area of my semicircle. And so my end game now is, how do I find volume if I add up all these semicircles? Well, the volume is going to be from 0 to 2, same thing as what we had over here, because I'm going along the x-axis, but it's the area of these semicircles. But really, what is the area of that semicircle? Well, we just said all of that really is this stuff right here. So I have this 1/2 pi, and then I have my 1/2 x squared minus 1/4 x plus 3 over 2, maybe. That quantity squared, since it's 1/2 pi r squared. So if I type this in my calculator, again, I probably would pull out the 1/2 pi, but if I type all this in my calculator, were you getting, and at the end I got to multiply by pi and divide by 2, I should get, it ends up being 3.88 pi units cubed, or if you wrote it out as all as decimals, did you end up getting 12.2? Hopefully that went well. I know, to be honest with you, squares, again, the first one being a square and the other one being semicircles, those are probably the easier of the two. I know if we have questions, it's probably the triangle ones on 74 from yesterday's homework. And so we can take a look at that too here at the end of the video. Is that good? Help each other out now, right? So again, sub-compose the video. We have questions. We have enough people in here that understand what's going on. I'm confident this. You can help your neighbor out. Come up to the board, share things with them. But this is something I want us to be able to do on our test on Thursday. Today, here's what we got cooking here today. I'll put up the answers again from our homework assignment yesterday, right? Some of you got a lot of this done in class, at least half of it done in class, so that was good. But then checking your other answers, let's do that. Today we're going to talk about the test here a little bit, what to expect when we take our test on Thursday. And then today is going to be some time to work here. This is, for some of you, this is going to be the toughest test we take in calculus this year. And it's not that it's overly hard, it's just It's complicated setting up these integrals to find volume, to find area, and knowing, okay, this formula and that formula and so forth. And so today we're going to have time in class again to do some review and work and help each other out in class. And so this is where having classmates, great value though. We need to not distract each other. We need to help each other out because this is going to be the biggest hill we need to climb between now and the end of the year. And so today, that's the hope here. And again, I put my phrase on there, prepare in such a way you won't be disappointed. We have today, we have tomorrow. Make this time count. So please be focused today if any other day. These were our answers from yesterday's assignments. I know some of us did 73 in class yesterday, so we got those set up. 74, some of you I know started, and we got pieces of it going there and stuff, but did you get these same solutions or not? Maybe at the end of the video, if you want to continue watching, you can tell the sub this, but maybe I'll come on and stuff at the end of the video and we can talk about probably the harder ones here is 74, maybe B, and maybe even D and stuff. If you want to see some of those, I can draw those up here and show you what those look like at the end of the video, if anybody wants to see that. Again, sub, if they need to pause the video and discuss some of these now together, that'd be awesome. If people are able to help their neighbor, that's why we're here. So help each other out. Now, let's talk about the test then. Here's what we need to be able to do on our test. Number one, where we started here, we need to be able to find area between two curves. And understanding if I do it in terms of dx, if I do it in terms of dy. If I do it in terms of dx, again, it's always really just adding up rectangles, really just adding up heights. It's always the top minus the bottom as I go along the x-axis. If I do it in terms of dy, that's always going to be my rightmost function minus my leftmost function because my pieces are going side to side. Finding the height of those rectangles goes side to side versus here finding the height of them goes up and down. And so finding bounds, I set the functions equal to each other where they might be. Then the big one, right, if I had to say this is what really most of this unit is, I need to find volume. And the three methods for rotating things around axis are my disc, my washers, and my shells. You need to know the formulas. I am not going to give you the formula for a disc, a washer, or the cylindrical shells. I need you to know those formulas and then know how to use them. The quick reminders here, disc and washers, these two kind of get classified together. Whatever axis I'm going around, my integration is going to be the same as that axis I'm going around. What makes shells different is that shells are always opposite. So if I want to find and rotate my area around the x-axis, if I use shells, it's going to be in terms of dy. And I think most of us have that understanding, but I need to know the basics of both of all three of these and recognizing when I should use one, when I should use the other. The last thing is I need us to find volume of cross sections, what we just did yesterday, and that's what the bell ringer was all about there. Again, I'm not rotating anything around an axis, but I'm using cross sections. And for your test, I would say these are the ones that I'm just going to be legit. Can I do it with squares? Can I do the rectangles? Those are pretty easy. Semicircles are not bad. Again, semicircle 1/2 pi r squared. A rectangle is just my base times my height. And again, they'll tell you the heights and say, hey, the height's always 3. A square is just my base, let's say my base squared. Or the last one is, and for this, I know on your homework you had isosceles triangles. I'll be honest with you, I just want us to be able to do equilateral triangles. If I have a triangle question, that's going to be equilateral triangle. So again, a triangle is 1/2 base times height, but I need to be able to add up those cross sections depending on which way it is. And then the last thing, just so again you're aware, all this stuff is applications to integration. I want us to be able to integrate both definite and indefinite integrals. So if I gave you an indefinite integral, I still want us to be able to anti-derive. Do what this is. On the test, again, you're going to see two things, and we can talk more about this tomorrow too when I'm back, but on the test, part of it's going to be without a calculator. And so I would give you functions that are easy to graph, that you should be able to graph them without a calculator to find area, to find volume, whatever way. But I want us to do the work all the way out, do the definite integrals, and work it all the way out without a calculator. The other part of the test is going to have a calculator with you. So some of the questions then are just going to be set up the integral and using whatever method that I either ask you to use, or you can just choose the method, finding volume or area. But then you can use your calculator to find the answer and just typing it in. Or they might just say even set it up and you don't even have to find the answer. I just want to see that you know how to set up the problem using disk, washer, shells, wherever it might be. So some of the test, again, is not going to be high intense work math-wise, but again, as you know, it's all about when do I use what, and how do I set it up, and why do I use this, and what's the radius, or what's the height. And those are things that you need to now get more reps in. I've been trying to give you reps. Some of you have been really faithful about doing the work with it. Some of you, I've been dragging you through the mud here in this chapter, let's be honest, and stuff, and I'm not really confident where we're at, where we need to be, but now it's time for us to start digging our way out of this mud hole we're in right now and be ready to have success come Thursday. Hopefully that makes sense to us, but that's where you're going to see a lot of this chapter. But again, I still want us to integrate if we have to integrate. So today, I'm going to go back to this. Whoops, back here. Really, the two things I'm going to ask in class. This is, can you find if the sub can pass this out? I want you to do this first. Make this the priority in class with your classmates around you. I want us to work on these review questions. Solutions are in Canvas, all the work. Some of them I know I have. I did the problem both with a washer and with a shell, so you can see, hey, oh, that's what it looked like with the shell method. Oh, that's what it looks like with the washer method. Now, when you get done with that, then this is going to be some more practice for us. It's not due until Thursday night, and so do this secondly. Again, tomorrow we can have some time in class to work on this, but this will be due at midnight on Thursday. But again, ideally do it before Thursday. Does that make sense? And so again, if the sub would pass out this review worksheets, we have time to work on this. Let's grind. Let's make some hay here. Let's start making this stuff make sense here. Tomorrow I'll be back to answer questions. We're going to do more review in class tomorrow because we need to. Sound good? Now, anybody that wants to, if you want to and you want the sub to keep playing the video, I would be happy to go back right now. Oops, sorry, back. And look at, in particularly, part B right here on 74. If you want to see the work, because I'm guessing that's, if we have questions from yesterday's assignment, I'm guessing maybe some cross-section stuff here. So if you want to zone me out. If the sub wants to shut it down, that's fine. Those of you that want to continue to watch, the sub can keep playing this, and we can talk our way through maybe how I find what the base is, and then how do I get an answer like this on, say, 74B. Sound good? Good luck, work hard, make me proud, and help each other out, right? Again, that's what we're here for, right? We're doing this together. This is not you versus the world. This is us together working these things out. And I feel bad that I'm not with you to help you, but this is good for you. So let's go back to, if you want to, 74, particular part B. And I think part B, again, they want equilateral triangles. So I have these cross sections with equilateral triangles for part B. So again, we're perpendicular to the, I think it's the x-axis, but I have these cross sections, equilateral triangles. Well, first of all, this is my function again, and some of you got this set up yesterday, but my function is a circle. X squared plus y squared equals 4. I need us, especially juniors, ACT coming up, we need to recognize this is the equation of a circle, and recognize that the equation of a circle is x minus h squared plus y minus k squared equals my radius squared. That's the equation of a circle. It's just that the h and the k, so this piece and this piece, that's the center of my circle. That's the coordinate for the center. And then obviously r is the is the radius. So when I look at this equation up above here, if I go to graph this, I should be able to know that this thing is going to have a radius, or sorry, have a center point where I don't have an h and a k, so my center has to be 0, 0 is my center of my circle. The radius, since this is 4, the radius ends up being 2. So I'm going to go out 2 this way, I'm going to go backwards 2, I'm going to go up 2, maybe, I'm going to go down 2. But if I draw my picture, I just get a circle that's going to be a perfect circle. Not quite perfect, but that's what my picture is going to look like on my graph. Sure. Now, again, my picture is not great, but there's what it is. If I want to find equilateral triangles, my triangles are going to be perpendicular to the x-axis. So these triangles are going to sit going up and down like this because that's perpendicular to the x-axis. That's going to be the base of my triangle. And then again, I'll try to draw these, and you guys can all laugh at me and stuff, but my triangles are going to be shooting out of the board where they're equilateral. And again, this isn't perfect, but can you kind of see they're going to be shooting out of the board here. But I'm going to be adding up triangles all the way from -2, and I keep adding up triangle after triangle after triangle as it goes, whoops, yeah, I shouldn't have kept drawing, Mr. Rick, because now I just kind of ruined it here. But I'm going to be adding triangles from -2 all the way till I get to the other side too here. So my volume equation, because it's perpendicular to the x-axis, I'm going to be going from -2 to 2 along the x-axis, but I'm just adding up the area of a triangle. And I just need to figure out how do I find the area of one triangle at any given time as I go across here. So to do that, what we're looking at is I need to find the base of this equilateral triangle. So the area of my triangle is 1/2 base times height, but because it's equilateral, this is what my triangles are going to look like. All the sides are going to be the same. The base of my triangle is going to be the distance between these two functions here, and we'll figure that out. To find the height again, the height of my triangle ends up being perpendicular to the base. And if this is a equilateral triangle, this is a 60. If I draw my height in, this ends up actually bisecting it, so I get a 30 and a 30. And so now it's just this. If this whole thing is my base, whatever this is, all the way across here is my base, what I would really want to look at is right there. I want half of my base for this. If I look at this 30, 60, 90 triangle. And so my rules for my 30, 60, 90 triangle, maybe I'll just draw this individually here. This is half of my base because it's half of the bottom of my triangle. If this is my 90 and this is my 60 and this is my 30, to find my height, because across from the 60, I take my base, which is the 1/2, whatever the base is, but then I take that answer times the square root of 3. It's my long leg here. And so my height is going to end up being whatever that is, 1/2 b times the square root of 3. So when I come back over here, if we're not confused yet, who could be confused here, Mr. Rick? I'm going to have 1/2 times the base, but then my height right here, this height, ends up being all this stuff right here, which is 1/2 my base times the square root of 3. Now if I simplify all that, move this down, if I simplify all that, I'm going to end up with 1/2 times 1/2 is 1/4, so I end up with a 4 on the bottom. I'll put the square root of 3 on top. Then I have b times b, which is b squared. This is the formula for my triangle, is square root of 3 over 4 times b squared. So that's one triangle. Now, the last thing that I need to know is simply this is, how do I find the base? Well, the base of this triangle, again, I go back to my picture over here, the base of this triangle is the distance between the top of it and the bottom of it. And so because I'm doing this in terms of dx over here, I want to take this equation and solve for y. So if I solve for y, I'm going to have 4, maybe I'll subtract my x squared over, and that'll be y squared. but then I'm going to take the square root of both sides, and so I'm going to end up with plus and minus the square root of 4 minus x squared. The top part of this thing, the top part of this parabola, that's the positive side of my square root. Again, this is not a function. A circle is not a function, but the positive side is a function if I just have the top part. The bottom part of it, which I'll make dashed here, that's the negative square root of 4 minus x squared. So if I want to find b, the distance between these two functions, I take the top, which is the positive 4 minus x squared, minus the bottom, which is the negative 4 minus x squared, and that's the distance between these two functions at any given time. And if I distribute my negative through, this is going to make this plus, and so my base, at the end of the day, my base ends up being the square root of this stuff plus the same thing. I end up with 2 square roots of 4 minus x squared. So when I come back over yonder, I need more board space. I'm going to slide this down. Come back over yonder. What is my b? Well, it's all of this stuff. So if I plug all that in, my area of my triangle is going to be the square root of 3 over 4. Then it's going to be 2 times the square root of 4 minus x squared. But then I have to do what with that? I have to square it. And if I square that, that's actually going to be 4 times 4 minus x squared. The square root goes away, but then I'm still multiplying that by the square root of 3 over 4. And what happens really nicely now at the end of the day, these cancel out, the 4's cancel out. So my area at the end of the day is going to be the square root of 3 times 4 minus x squared. So what is the area of my triangle? Come back over here. Well, the area of my triangle is the integral from -2 to 2. Because I'm starting at -2 right here, going all the way over to 2 on the x-axis. But it's going to be the square root of 3 and then 4 minus x squared dx. Again, I could pull out the square root of 3. You could anti-drive this by hand if you wanted to. If you type this in your calculator, again, the answer that they're getting is they're pulling out the square root of 3, so they're pulling that out. I feel like I should just do this by hand now, Mr. Roick, since I'm here right now. I think I might. Some of you with your calculator, if you want to do it that way, that's fine. But I'll have the square root of 3 pulled out. If I anti-drive this, I'll have 4x minus 1/3 x cubed. But then I'm evaluating at 2 and -2. And at the end of the day, multiplying by the square root of 3. I'll plug in my 2. So I have the square root of 3 times, plug in my 2. I'm going to have 8 minus, this will be 8/3. If I plug in -2, I'm going to get -8 minus, actually I can turn it into plus 8/3. So I get that. If I get a common denominator, this would be 24/3. This one's going to be -24/3. And so at the end of the day, I have the square root of 3 times. Over here I have 16/3. Then minus, over here I have -16/3. This turns into plus, and so what do I end up with? I end up with 32 over 3, and then I have my square root of 3 coming along for the ride. Units cubed is the total volume of all these equilateral triangles. Some of you I just put to sleep. Some of you, maybe that helped a little bit. But that's how we got to that answer over here. Again, rectangles, squares, semicircles, I think are way easier. The triangle ones are the tougher ones of what they are. So the rest of the period, though, let's keep working. And good luck to you, and I will see you tomorrow. Get lots done. I want this review sheet, all these questions tried, completed, before I see you again tomorrow morning. Good luck. Thank you for your work. Bye.